A very good morning, my dear students. Today we shall try to understand what is meant by an retaining wall. Now, coming to this retaining wall, what is the use of a retaining wall? It generally is used to retain earth or other material to maintain the ground surface at different elevation on either side of it. That means to say, here you have a lot of height, so you have a small barrier being constructed. So this is retaining the earth here. Such a wall is called as a retaining wall. That means to say, this retaining wall, the materials can be used with an, here what you see the pictorial representation is of used of an boulders or rock. Like that, it can be concrete blocks can be used, or timber can be used, or boulders can be used. Generally, it is used to retain the soil at a slope which is a greater and would naturally assume at a vertical or near vertical position. Now, let us try to understand the various components of an retaining wall. You have the various components are stem, toe slab, heel slab, counterfort, and shaky. Let us try to understand with an pictorial representation the various components of this wall. So here you are seeing a backfill, and this is an open ground where you have a basement construction. So hence this wall is constructed here. This wall is called as an retaining wall, and this part is called as stem. This part is called as an base slab, which has the front portion is called as an toe slab, and the backside portion of this base slab is called heel slab. And now when you have an above soil is called as an subsoil soil, and the existing ground level is at this point. Now you have a lot of earth trying to push, hence this is called as an active earth pressure. Due to active earth pressure, this retaining wall may slide away. Then to stop the slide away, we provide a key called as an shade key. This is called a shade key. So now, what are the applications of an retaining wall? We shall try to understand here. Generally, it is used in construction of basement below ground level in buildings, or in bridge works where we have the wing walls, like that to retain slopes in hilly terrain roads, side walls to provide a lateral support to the embankment. So now with this, we'll try to understand the concept of the types of retaining wall. The first type is called as gravity retaining wall, and next we go with cantilever, counterfort, buttress, bridge abutment, and box culvert. So today we shall try to understand the theoretical concept of all the types. Now the first one, generally in our syllabus of PTU, we have gravity retaining walls, semi-gravity retaining walls, cantilever retaining walls, and counterfort. Anyhow, we shall try to understand the other types of retaining walls also as illustrated here, that is buttress wall, or bridge abutment, or box culvert. So now we'll go ahead with this. The first kind of retaining wall is called as an gravity retaining wall, where this is the backfill and this is the existing ground level, where a wall is constructed here, that is called as a retaining, the pressure is called retaining wall, and here the stability of this wall is maintained by its own weight. Such kind of retaining wall is called as a gravity retaining wall. Generally, the height of this retaining wall is about 3 meters only, and the soil above the ground level above here is called as subsoil. So now with this, we shall try to understand second type, how this structural action of a gravity wall will be there. So gravity wall resists the earth pressure exerted by the backfill by its own self weight, that is nothing but called as dead load, we generally call, and it is usually built in stone masonry and can go with a mass concrete also, and it provides stability by virtue of its own self weight, and rather it's called a massive in size. Generally, if we use a mass concrete, these walls are can go with a height of maximum of 3 meters. Like that, we have the next kind is called semi-gravity retaining walls. Now we have the earth pressure here. Due to the earth pressure, this may buckle away. To avoid when it buckles away, you have the compression stress and tensile stress here. So hence, to reduce the tensile stress, we use a minimum tension reinforcement here. Such an wall is called as a semi-gravity retaining wall, where the fluxural resistance is resisted by a minimum reinforcement. Such a wall is called semi-gravity wall. So the difference between a gravity wall and a semi-gravity wall is, in a gravity wall only plain concrete or stone masonry used. Here in semi-gravity wall, plain concrete with reinforcement or stone masonry with reinforcement is used. Such kind of wall is called as a semi-gravity retaining wall. With this introduction of a gravity retaining wall and semi-gravity retaining wall, we shall try to understand what is meant by a cantilever retaining wall. That means to say, whenever the height from here to here is more than 3 meters, then that kind gives a cantilever action. This is called as a cantilever retaining wall. Generally, we limit this height to up to 6 meters. So it consists of an vertical wall, which is called as a stem. This part is called the toe slab, and this part is the heel slab. In next class, we shall try to understand the structural action of a toe slab, heel slab, as well as stem, to understand why this kind of reinforcement is provided here. Now, let us try to understand the geometry of a retaining wall, cantilever wall. This might be a T shape, that means to say this is called T shape, or sometimes I don't provide a toe slab, then it becomes an L shape. And as I told you, due to the pressure of the earth, this might slide. Hence, to grout, we provide a shade key. Hence, we may have a T shape with a shade key. Hence, we have 3 kinds of retaining wall, cantilever retaining wall. One is called as T-shaped retaining wall, or L-shaped retaining wall, or T-shaped with the shade key. So this is called as a cantilever retaining wall. If by chance the height between the ground level to this level is more than 6 meters, then we go, the cantilever action is more, then we go into an counterfort retaining wall, where we provide counterforts in fashion of a beams, a tapered beam or a triangular beam. Hence, this slab is supported on these 2 beams. Hence, this become a one-way slab, or as it is continuous, this becomes a one-way continuous slab. Like that, heel slab is also becomes an one-way continuous slab, except the toe slab becomes a cantilever part. Hence, the retaining wall designed by using a counterfort is called as a counterfort retaining wall, where the stem and the base slab are tied together by a counterfort at suitable intervals. That means to say, the intervals may be 3 meters. Anyhow, when we come into the numerical problem, we shall try to understand the concept of that. And this is economical for height over 6 meters. Below 6 meters, we use an cantilever retaining wall. After counterfort retaining wall, the same counterforts are provided to the other side, that is called as a buttress wall, where modification of counterfort with counterfort is called a buttress provided to the other side. Such a kind is called a buttress wall. The similar way, if I connect the top of the stem to the deck slab like this, combined, framed, then this is called as a bridge abutment. So when this is connected by a bridge duct to a stem, is called as an bridge abutment. But this is not designed like a fixed joint. This is an hinged joint here. The same way, if I do an underpass where the entire the bridge duct again coming here, again coming over the slab like a box, is called as a box culvert, where these joints are designed like a fixed joints, fixed frame connection, fixed frame connection, fixed frame connection, and fixed frame connection of the joint. Such a retaining wall where I build for the underpass is called as a box culvert. It may be single box culvert or multiple box culvert. Now coming to the various kinds of forces coming on a retaining wall are lateral earth pressure, self weight of the retaining wall, weight of the soil above the base slab, surcharge, soil reaction below the base slab, and frictional force at the base slab. Hence, now coming to this, the pictorial presentation. Now, this is the soil earth pressure, the self weight acting W1 and W2, and as usual, I told you the surcharge is nothing but if the angle of inclination is more, it's called surcharge, we get the load. And same way, soil reaction, that's called upward pressure, then the frictional forces. In next class, we shall be talking about the design of a cantilever wall. Anyhow, as a summary of what we have learned today is we have various kinds of retaining wall. Basically, retaining wall is used to retain the soil pressure, which holds the soil pressure. And this can be filled up by any materials, concrete blocks for a smaller height, timber, rocks or boulders, and if it is and more height, more than 3 meters, then we go with the RCC retaining wall. Hence, coming to this, the various kinds of retaining wall we have learned, that is 10 types is gravity wall, counterfort, and the next class we shall talk about the later matter. So hence today I shall end up the class. The next class will be doing the design of an cantilever retaining wall. So hence goodbye to everyone for the day.